Good evening, everybody. Hey, guys. Sorry, not Deborah. Apologize. Really happy to welcome you all tonight. It's my great pleasure to introduce my friend Paolo Tombesi, who's our speaker tonight at the annual Gordon H. Smith Lecture in Practical Architecture, which you know is something I'm very interested in. The Gordon Smith Lecture was established by Gordon in 1980. He received his Bachelor of Engineering degree from Yale in 1957, and his generosity extends to Yale College as well, where he supports scholarships for 2 of our undergraduates each year. If you're a student and Mr. Smith's name sounds familiar to you, it's because our heavily used conference room, room 322, on the 3rd floor is named in honor of Mr. Smith and his late wife, Norma. And if you're a practitioner, you know of the highly regarded consulting firm he founded after leaving Yale, the Gordon H. Smith Corporation, which specializes in exterior walls and cladding. I actually worked with Gordon myself on several projects during my practice career, and it was a pleasure. Past speakers in this lecture series include the great structural engineers Robert Silman and Guy Nordenson, as well as Cecil Baumund, Elizabeth Plater-Zybeck, and Liz Diller, among others, and we're happy to add Paolo Tombesi to that esteemed list. Paolo is a professor of construction and architecture at the Swiss Federal Institute of Technology in Lausanne, where he has worked since 2016. Between 2017 and 2020, he directed the university's Institute of Architecture in the city. Prior to his appointment, he held the chair in construction at the University of Melbourne, where he worked for 20 years, and where he held the professorship of building until 2021. A former Fulbright Fellow, he has a PhD from UCLA, where he studied the distribution of technical design knowledge in the building industry. He's been working as a consultant for state and federal governments on research and heritage issues, most notably on the 2006 World Heritage Listing nomination to UNESCO of the Sydney Opera House. Paolo has long nurtured an interest in the relationship between the intellectual dimension of building and the socio-technical aspects of its physical construction. The generation and management of design information constitute an important focus of his work, both at an industry level and within specific projects in that context. By following and delineating the social patterns of these projects, unpacking exactly who is responsible for design, he seeks to understand functioning and evolution of the construction sector beyond conventions of traditional project delivery. I'd like to say personally that I came to know Paolo in 2006 through Professor Emerita Peggy Deemer, who's with us tonight, when he made a terrific contribution to our book, Building in the Future, Recasting Labor and Architecture. His essay on the cultural separation of design labor was a continuation of his scholarship exploring the relationship of design process, representation, and technology. Since 2020, Paolo has been conducting research in collaboration with Australian colleagues whose names I'm going to murder in the best tradition of Dean Burke. Luciano Cardellicchio, close enough? Okay. And Paolo Stracchi, but both gentlemen are here with us tonight from the University of Sydney on the technical design for the Sydney Opera House and the very interesting dynamic, as always, between architects and builders. Many of you may know that the Opera House's architect, Jan Ussen, was fired by his client and actually never saw the finished building. You'll learn more about this and more about this project in tonight's lecture entitled Sails, Octopuses, and Beds, the Sydney Opera House Turns 50. Please join me in welcoming Paolo Tombesi.
Well, let me first find the right prescription, because otherwise I can't even see the slides. This is it. Well, thank you to the School of Architecture at Yale, Professor Bernstein, Dean Burke, for inviting me to subtropical Yale to deliver the Gordon Smith Lecture in practical architecture. And this is a very important occasion for me, not only academically, but also at the personal level, because it ideally completes a loop that started over 30 years ago. 30 years ago, when I was a PhD student at UCLA, as Phil Bernis reminded us of, doing a thesis on the construction of the Walt Disney Concert Hall, for which Mr. Smith was the curtain wall consultant. So one day, out of either scholarly desperation or youthful entrepreneurship, I decided to write him a letter to New York and ask him whether we could actually discuss the project. And to my surprise, 2 or 3 weeks later, a positive reply, came in my letterbox, and after that, we had 2 or 3 meetings that were very, very important for me, because first of all, they shaped my thesis, but they also shaped my view of what the building industry is. And in fact, it is the view that I actually used when I participated in that symposium here at Yale, organized by Peggy Dima and Phil Bernstein. So while closing the loop that I opened 30 years ago, I really want to take this opportunity to thank Gordon Smith, I think a kind person and a true patron of academia, who's also responsible for my being here today, not only because of the sponsorship of the event, but I think through the generosity of spirit that he has shown in other seasons of our life. So thank you very much for what you've done for me before this event. Now, we go to the today's event, the anniversary of the Sydney Opera House, 50 years since its opening by Queen Elizabeth. And I'm going to use these 3 nouns, cells, octopuses, and beds, to provide you with a slightly alternative view of the greatness of this building and its significance in the history of architecture and construction. What I'm talking about is a building that started its proceedings in 1956 after a competition was organized by orchestra conductor Eugene Gossens. That is the rendering of the maquette that was actually provided to the participants in 1956, what Gossens envisioned for Bennelong Point. Jon Utzon wins the competition in 1957. 1959, ground is broken on Bennelong Point, and 15 years later, Queen Elizabeth II opens the building on October the 10th. So 50 years the 20th, 50 year last week. Between 1958 and 1973, there have been 3 stages of construction which essentially materialized the building. The first for the podium, 1958-62, the second for the superstructure and the sails, and the third for the glass facade and the interiors. Since then, since the opening, but even before then, the Sydney Opera House had really become a very powerful signifier, a very powerful symbol of the country, and actually a mirror of its society, from latest fashion trends to societal events like the latest COVID. And so here you see the Sydney Opera House appearing on the front page of the Sydney Morning Herald during lockdown. Now, in 2003, the day in which the entire nation was glued to the television because of the start of the Iraqi conflict, 2 social activists climbed the ridge of the Sydney Opera House to write "No War" on the sails. They were later convicted, 6 months in prison, $151,000 in fines, but they said in an interview only that building could have conveyed that message to the rest of the world. So be that as it may, 4 years later, in 2007, UNESCO decided to inscribe the Sydney Opera House into the list of World Heritage Sites. And the outstanding universal value that had to be, declared in order to make it worthy of such an honour contains a number of truisms on motherhood statement, but there is a last one which says original design, concept, and unique approach to building that gives impetus to a collective creativity of architects, engineers, and builders. And this was an interesting thing to find into a building which was listed as World Heritage. Now, if we look at the various protagonists of this story, we have Jon Utzon, the architect for stage 1 and 2, Ove Arup, the British structural engineer that was the engineer for the Sydney Opera House, as well as the project manager for stage 2. Then Peter Hall, the architect that replaced Jon Utzon with stage 3, the interiors and the waterproofing of the building. And then Sir Manuel Hornibrook, which was an engineer, an Australian engineer and general contractor for stage 2 and 3. If we look at the history, that we know the public history of the building, there is a lot to know about Peter Hall, the architect for stage 3, given its very sort of problematic relationship with the project, and given that he replaced Utzon. But when it comes to the relationship between architects and engineers, it's Utzon and Ove Arup that steal the stage. So they take front stage. There is almost no mentioning of Manuel Hornibroek. This is a man who's been a company that's been almost excised from history. There is, however, a certain proclivity on the side of architectural commentators and culture to actually look at the Sydney Opera House as well as any other building as a masterpiece, and then a piece that is the creation of the master. So here you can see the most incredible exemplification of that. This is something, this lighting of the cells is something that comes up every year in Sydney, on the Sydney Opera House with laser beaming. And as part of the annual Vivid Light Festival, there was this drawing that was produced, that was projected on the Sydney Opera House, which is a fake. And it is a fake because it has Utzon's signature on the right, but in fact it has an Ove Arup drawing right in the centre. Utzon never produced that drawing. And so it's part of this particular paradigm. Now, one of the things that the things that we're going to talk about today come from a multi-year research project that I've been carrying out for the last few years with two colleagues of mine, Paolo Stracchi from the University of Sydney and Luciano Cardellicchio from the University of New South Wales, together with other people. If anyone is interested in the literature that we produced up to this point, there is a code there, and you will find everything that has been published. Now, the problem and the holy grail of this particular project is drawings. It's interesting that with the Sydney Opera House, 25 monographs have been produced so far. If you open them, there are no construction documents. So the construction documents of the Sydney Opera House for a long time have not been known. We know the construction drawings of constructions at the stage 3. We know the construction drawings of particular packages. We know Utzon sketches, but until very recently, we didn't have the construction drawings. So my two colleagues that are much more rigorous than me and persevering than myself, decided to actually go on this search, and eventually they found the drawings in the Inland Empire of New South Wales. So what I'm going to do today is to actually show you some of these drawings and see how the drawings tell a different story about the building. And we're going to do that by focusing on what is called the spherical solution. So the great idea that Jorn Utzon came up with in order to resolve the structural problems that had beset the resolution of the sales of the building for 5 years, from 1957 to 1961. Essentially, he decided to move from free-form shells to ogival walls with radial ribs by turning all the main shells into curvilinear triangles that formed by ogival arches that stood on one vertex, in fact, on two vertexes called pedestals, if you put them together. So all triangular sectors of the cells belong to the same sphere. In a 1973 report, Ove Arup produced the first great research report produced by Ove Arup at their office in London. They produced the series of structural solutions that had been adopted between 1957 and 1962. And here we're talking about the last one, essentially, L and M, but more M, that in fact shows how the structural logics of the building changed, notwithstanding this ostensible simplicity that was added to the project. Now, Utzon produces this particular solution in January, publishes the solution between January and March 1962. This is the famous yellow book, the cover page of the document that was given to the New South Wales government. The drawing, one of the most famous drawings in the history of 20th century architecture, was actually made by a very young Raphael Moneo. 23 of age, he was actually spent 6 months at Utzon's office in Helderberg. Without ever going to Australia, this is Raphael Moneo's work. In fact, if we actually open up the yellow book, which consists of 42 drawings, we have 3 to 4 drawings that relate directly to the spherical solution. There are 3, I put 3 here, all the work of Raphael Moneo. These are 4 drawings that Raphael Moneo produced in Utzon's office, plus an elevation of what the Sydney Opera House would look like according to the solution. Notice that the sails are very, very, very visible, but not the other parts of the building. So whilst I have to go back, okay. So whilst they didn't put much time and energy, I would say, into the production of that information, at least until that point in time, Utzon did some very, very good shrewd marketing work. The first one was a documentary for the Danish television, and another one was an interview with the Australian Broadcasting Corporation in Sydney, in which he explained essentially what were the topological and geometrical logics of the sails. And he says, and we're going to do this by building a factory on the site to produce these ribs. Only one form, divided into smaller parts, is actually necessary. The forms are movable to enable us to mass produce segments. And so while Utzon, in a sense, communicated this idea and made that become a forming idea of the history and the mythology of the Sydney Opera House, there was other art that took over the production of the drawings in order to define the anatomy of the building and its various pieces out of this idea. And in fact, these are some of the drawings that they produced, not so much the central one, but the other ones to the right, in which you can see the initial complexity of all the components. There are dozens of these drawings. I'm not going to show them to you because there would not be enough time. I just show you this particular drawing, which is in fact the one that was erroneously attributed to Utzon in the public event at the Sydney Opera House, which is an incredible drawing done by Arup, in which architecture, structure, and eventually the fabrication of the components come all together. Arup spends 2.5 years between 1962 and 1964 producing most of the documentation, but at the same time, he needs to talk to the constructor. And so Arup convinces the government to bring in a particular contractor by the name of Hornibrook Company, which was a builder of bridges in Australia and some of the most famous segmental arched bridges at the time. Why did Utzon need a constructor at that point? In fact, the first contract that Hornibrook got with the engineer was that of the design consultant for 4 months in London. So the contractor went to London in Arup's office to talk about the design of the construction site. The reason why they had to do it, because the genie of the place was very, very difficult, in a sense that Utzon decides to use the first stage with the podium and the program of the building to build the topography of Bennelong Point. And once it built the topography, this podium of Mayan origin, as we all know, there is not much space left to actually build the sails on top of it. And in fact, Arup calls the Hornibrook and asks him to devise a strategy to build on that. And Hornibrook starts by threading very, very lightly on the construction site by proposing a Y-shaped system with the elevated truss and the traveling cranes. They go to France, get 3 tower cranes, the tallest tower cranes in the world, and they bring them to Sydney. Here you can see 2 images, 1963 roughly, of the organization of the site with the I-shaped 3 gantry rail tower organization of the cranes. Now it's interesting, this photograph is interesting because everyone is waiting for the Sydney Opera House to emerge out of this podium. And in fact, what you see here are 2 walls, 2 strange walls that sit right in the middle of the site. And the reason why they are there, because they are the most important part of the Sydney Opera House. And they're called the Octopuses by Arup, whereas in the vocabulary of Utzon's office, they still remain the side shell. But they are self-standing tripods that are formed by intersecting arches that converge into a special piece named crown, the one in yellow in the photograph. The middle arch in the double A is effectively supported by full-height wall, the 2 images that you saw in the other image, and the other lateral arches actually act as supporting joint on the main and side shells. So everything falls onto the Octopuses. Then the system is completed with a series of pieces that are precast or cast in situ. Very complicated scheme that somehow doesn't respond too well to the idea of industrial normalization that had been made public in the interview. So the one on the right, on the left, is the image of the wall, and the one on the right is the image of the same wall, which is completely concealed from view today. Also because there's a very, very smart typological arrangement, and so it becomes the stage wall that divides the foyer of the building from the actual concert hall. Now, that first year is actually spent trying to put the tripods together. The tripod, and particularly the main one, is on the critical path of the project. If you don't make that one, if you don't build that one, you cannot build the Sydney Opera House. And so, what you see, there is a lot of energy that is spent doing that. Even Peter Rice works at the resolution, as a young engineer, works at the resolution of this particular problem. So much so that at one point, it's starting to build some pressure, and they put a column onto the sort of the bending arch to the left. What you can see here is the complexity of this particular element with the octopuses that are right above the column. Then you have the ribs, and then other two octopuses that you can see in perspective. To the left, you have the drawing by Arup when Utzon was already in control of the project, with one of the four invisible columns. Now, if you start building that one, we also have to start understanding not only how to support the arch, but how to pile up all the components that are the precast component of these arches. And these arches are a very, very difficult form, because what Utzon does but doesn't say is that, in fact, the centers of the spheres from which the various sails are taken out have different centers. And so when you put them together, they don't comply entirely planarly, and so you have to produce a warp arch. On one side, you have the normal spherical surface. On the other one, you have another spherical surface, and the various components of the arch need to twist as they go up. So, in fact, you can see here the precast component set up by the building contractor. You can see them organized. I don't know if I can do this. Well, you can see them right by the end of the harbour, and as they are built up on the central image. On the other side, on the other two images, you see the incredible amount of complexity that the contractor had to go through in order to take a precast component which had one side which was constant and the other side that would actually change. So they set up this particular system called cradles, where you have a system, and this is a drawing by the building contractor, a system that goes up on this steel trail, and then as it goes up, one side of the cradles changes the angle. You can see can be organized at the beginning, and so it changes the shape of the crane. You can see on the top element there is a drawing done by the contractor. So this is a contractor drawing, Hornibrook's drawing, that studies how these various things can be lifted up and turned in space in order to be put on the cradles. But that's not enough, because once we do that, we have to understand how to prop it up, how to support the arch during its construction. And in order to do that, we need to produce some telescopic props, because the building side of the Sydney Opera House is still open. We have the podium with all the functional programs. We are building the sails, but we haven't built the theatre yet. And so we have these big gaps into the section of the podium, which you also need to use in order to prop the arches up. And so here you can see the telescopic arches that were invented by the contractor with a series of joints that I'm not going to explain here. It will take too long. There is a reason why I'm doing this in this way and going this fast, so bear with me. Once we do this and we bring up the arches, then we have to bring them to a conclusion with the crown piece. And the crown piece is an interesting one, because at the one hand becomes the element that brings all the four legs of the arches together. On the other, as a precast piece, becomes the sacrificial formwork for the cast in situ pour that will allow all these arches to be brought together and become cohesive from a structural point of view. So you can see here not only the precast element of the crown and the moment is actually lifted out in place, but also the drawings that Arup had to produce in order to define the main profile with the sacrificial form, then the reinforcement of that form once put in place, and then the position of the tensioning once the entire thing had been done up. Now, I've done this in order to give you a sense of the pressure that all these people were being subjected to for the 2 years that took to produce the various octopuses, because it was one problem after another, and we were going on a very, very tight schedule. The other thing is that none of this work is visible today. So this is work that was preparatory for the sales, but it was not part, if you will, of the architecture. Now, the other thing, though, is that it's not always the case. So there is a large part of the work of these people, the engineer, of the contractor, that has very much become visible today and defines our experience of the building. And that has to do with the pedestals that are part of our experience of the building as we walk through. The structural coherence of the walls does require that tensioning and bracing systems are put in place during and after the assembly. And so that produces a variety of different anchorages and pockets. And so, in fact, these pedestals that, ideally is only there to support the ribs with the arches, in reality need to acquire a textural finesse that responds to all the structural needs of the building. And so here, Arup, but as well the contractor Hornibrook, need to produce an incredible amount of drawings, very, very specific, in order to describe every little hint, nook and indentation that appears in these places. If you want to see the difference between the elements under construction and today, well, the colored photograph is what you see today when you visit the Sydney Opera House, and the other photographs are under construction. Now, it's interesting because our experience of that space is based by and large on these things, the reasons of which are essentially structural and constructional. The same thing happens for the, our experience of the octopuses, and also the way in which the ribs go all the way down to the ground, essentially for the same reason. They need to be post-tensions, and so we need to find the way to bring them all in and find ways to jack them up and tension them. And in fact, when you go today at the Sydney Opera House, not only looking at the pedestals, but looking up, what you see is the work of the people that built it. There are essentially no drawings done by Utzon in order to detail this particular work. We do have sketches which we have found where Utzon's office, in a sense, approves some of the work, but this work comes from a different walk of professional life. Then there is another component, which is the invisible component that has to do with the stability, the structural stability of the cells. The vertical one has to do with the system of spigots and vertical contacts that the contractor put in place in order to make it possible the fixing, the epoxy fixing of the various segments before post-tensioning. But also we have the lateral bolting that Arup considers to be necessary for the structural stability of the place, which in fact will produce an enormous amount of complexity in terms of the casting of the pieces, as I will show you in 5 minutes. When we go and look at some of the other drawings that are produced in that respect, we can see the second proposal for the lateral bolting of the radial segments in 3 or 4 paths along the length, the height of the sails. Then we have in the middle something by Morgan Bosprius, one of the Utzon's right-hand architect. Okay, Utzon office in August 1963, and then eventually all these pieces that find their graphic representation into Arup's working drawing. So here we are. In 2 years, we go from the construction site, which is organized on this Y-shaped gantry system, with the layout of the building materials, indeed as imagined by the building contractor, and a site which is becoming more and more saturated with stuff. And so here we have to make a decision, take a decision on what it takes to build something which is made out of a series of microsites, because all the octopuses produce microsites of their own, in the sense that they need their own scaffolding, their own propping, operations. And then you have the sails that need to come up from the podium, like as a miracle of tectonics. And so in order to do this, everyone goes back to the solution that the contractor had imagined for the first, in the very first place in 1962, which is the use of those gantry system and the use of the pedestals, and only the pedestals, for constructing the sails. And so here we go, we arrive to one of the most incredible pieces of machinery in the history of modern architecture, which is the erection arch. A radial, movable centering that follows the shape, can follow the shapes of the ribs being built under any temporary configuration. And this thanks to a telescopic mechanism that provides space for the progressive insertion of the precast components I'll show you. So it consists of two half arches of triangular steel lattice with a section that goes from 3 to 6 meters, and a crown piece that features a ball joint. I'll explain to you why in a moment. And then eventually they attach themselves to the various ribs, or to the segments of the ribs, through something which is called a needle beam. These are images of the arch, the erection arch in various configuration. The arch was actually invented and documented and structurally calculated by two people at the contractor's office, Dan Gore. He was the general manager in charge for the Sydney Opera House, and a French engineer, Joseph Bertoni, with a very, very adventurous life in France, in the concentration camps as a submarine pilot. These are the drawings done, I think, by Bertoni, particularly the drawing at the top. If we want to see how this thing works, how the Sydney Opera House, how the sails were actually built, starting from the Octopuses, we do this. And one fell down. This is thanks to the students of Paolo Stracchi in Sydney. Anyway, you get the gist of what I'm trying to say, okay? So, the problem is that it's not just a matter of making a diagram that does little, funny movements along an axis, but rather to actually detail all the components of this particular thing. And so you imagine that in order for this arch to move in this way along a circumference from one particular point, he needs to have a carriage, a base that can actually move and allow it to move progressively, rib after rib. They can't move the arch. The arch must be pinned onto that base. And at one point, the arch, given that we have the arch that has to make space to get the last piece, at one point the rib is finished, therefore the pedestal is completed, but the arch needs to be standing on false work, because otherwise there is no way to mount the last piece. And that's why they invented the pedestal extension there. So it is something that allows the erection arch to go off the line of the pedestal in order to complete the building. The other thing is that with this erection arch, once you start moving along the sail has a curvilinear spherical surface. So that means that the arch must do this and move along the ball point. Otherwise, it will go straight. It will not be able to cover the entire surface. So there has to be a joint that allows the arch to move in this direction, but there also needs to be another joint on top that does something else, because the arch, as it moves up, it goes further and further from the next piece, because the pieces taper out. And so, in a sense, even this thing is something that requires a systemic view of all the drawings, all the parts of the building, and above all, the documentation of this. Last but not least, we have the needle point. So the elements that allow the segments that have been precast to be attached to the erection arch on one side through the needle that we have near the lattice of the of the arch, and then you need to block it on the segment of the rib that is available in such a way as to be able to insert the segment into the space that has been made available for that. And this is the systematization, if you will, of that. So they organize it in two pieces in such a way that you have the piece that attaches itself to the erection arch, which is always the same. And then the other pieces that have to attach themselves to the ribs, to the segment of the ribs that taper out, that need to change width, because otherwise it can't actually reach and attach itself to it. And these are the images of the pieces with the needles attached, and once they're attached, how they actually been put onto the sails. Now, last but not least, the pieces. What are we going to do? How are we going to make the pieces of the Sydney Opera House? And here, the contractor has a great role to play. So from the very beginning, he starts on the side trying to plan how to organize the very little space available. And these are the parameters that he has to use in organizing production. They need to produce 2,500 precast segments. They cambered, double tapered, dimension bound because of the site, weight limited because of the covered frames. They need to be lifted, scaffoldable, post-tensionable, so on and so forth. And so in order to do that, they organize a construction site, a casting yard, where they organize a series of elements that are called beds. And the beds are 9. They organize 9 beds, so sometimes they become 10, but essentially 9 beds that are served by 2 central spine cranes, and each bed produces specific pieces. And each rib of the Sydney Opera House has up to 13 pieces, and when it's those 13 pieces, they contain 3 types of radial segment that are full, hollow core, and void. And the contractor organizes 3 types of bed for that. One that goes from piece 1 to piece 5, one that goes from piece 6 to piece 9, one from piece 10 to 13. Because the Sydney Opera House has shells or sails of different size, not all the pieces need to be produced in the same way. So in fact, the number of beds that have been put on the casting yard are directly proportional to the number of pieces that need to be cast. In order to be precise onto this, we need to make sure that everything going to fit, each piece going to fit into the other piece. So anytime that there is one piece 1 to 5, the piece number 5 is actually extracted from that form and becomes the first piece of 6 to 9 in such a way that there is a seamless connection between the two. And that's what you see in this photograph and the drawing done by the general contractor to show how the temporary formwork for that piece must be put in place. And these are the drawings produced, some of the many drawings produced by the general contractor to make that particular thing possible. Here we have a clear attempt to systematize production also by responding to the various parameters that are made necessary from the form of the sails. So you have mechanized casting bags that facilitate the stripping of the forms. You have adjustable inner formworks that allow us to use exactly the same formwork when the various elements changes in size, and also have adaptable cross-bracing form for the top of the larger segments, because given that the rib changes in width, even the bracing must change. And all this is done in such a way not to complexify things, but to make them simple in such a way that the forming, the pouring, the stripping, and the mounting of these pieces can be as seamless as possible. So you can see what the inventiveness and the complexity of the system. So of course requires a series of micro projects and micro design to be inserted into the formwork. So the form or the bed is one thing that looks very efficient, but in fact it's something that requires the invention, the design development, and design resolution of a number of pieces, such as the bulkheads, for instance, that separate one segment from the other. You can see those two drawings there, or even the internal formwork, which in the drawing right above me also has the mechanism to stretch the size of the formwork in order to respond to different sizes of the segment. And then here, Arup decides that in fact the cross-bracing is one of the most important parts of the taller segments, because you have to understand that we still have tower cranes that can only take a certain weight, up to a certain weight, considering the radius of the crane. And so there is a desire to lighten the very components as much as possible by providing this bracing on top of it. So here you see the drawing by Arup and the response to that particular drawing by the general contractor, how they're going to do the preparation of the formwork. And then here you have Arup that decides, because of the lateral bolting, to start putting together one or two segments that do particular things. And in response to Arup, then the general contractor, these are modeling simulation done by my colleagues. And so the general contractor has to produce a casting system that responds to Arup requirements. Now, why have I said all this, and why have I said it at such a frantic pace? Because if we go back to the initial interview, and in a sense the rhetoric of the conventional narrative of the Sydney Opera House, this is a building that has actually been built on a very efficient way of optimizing the geometry of the building. So once again, a factory on the side, one forms only movable to enable us to mass produce segments. In reality, this is something that the incredible patience of my colleague, Paolo Stracchi, has produced to show you what is the level of variation into one sail, only one sail of the Sydney Opera House. The level of variation that depends on the construction elements that you need to put in place in order to make that geometric configuration work as a building. And so here what we have is that out of 2,400 pieces on the sails, 1,600 are one-off. Okay? One-off in the 1960s, so at the time where this particular work had to be achieved through manual means. So this thing for us is actually quite important, because he tells us how difficult it is to build something and why we should respect the people that do it. On the one hand, you have a very, very famous image of Woodson that's actually explaining the spherical solution to the public. And on the left, on the right here, you have the number of drawings that had to be produced by the general contractor in order to respond, to put the instructions in place to build those sails. I'm talking about the drawings for constructing it, not the drawings for calculating, for describing the anatomy of the building. So in a sense, it's difficult to continue to think of this as sort of the eureka moment that an architect comes up with, without considering all the incredible amount of intellectual work that goes beyond that particular intuition to make it come to fruition and materialize it. Now, I can stop here with a few things that I thought I could say at the end, or give you 5 minutes of reflections on this and why we think it's important. So, Phil, we have 5 minutes? Okay. We have 5 minutes. Why should we do all this work? This work has taken 3 or 4 years, and I can tell you the patience of my colleagues, for me, would have been already gone after 6 months. Why do we do this? And why is it important to do it? And I think it has to do, one of the things that we agreed has to do with is history, which at the moment is a major is a major, I think it's a major issue. It's a major issue because not only in architecture, but in architecture, for example. Where is history made? And where is architectural history made? Do we make history through ideas? Do we make history through the materialization of those ideas? Do we make history by describing those ideas of those processes? And so here, of course, you can imagine that we tend to sort of have a proclivity for the history made on site. Because essentially it's only through the history made on site that we can actually see the distance between ideas and the way in which ideas have come to fruition. And so if that is the case, what does that history tell us? What does the history that brings together the sails, the octopuses, and the beds, or the segments of the bed? Well, certainly, he sort of confirms the statement in the UNESCO Declaration of Outstanding Values. There is evidence of collective creativity. I didn't coin the expression, it was just there with UNESCO, but there is evidence of collective creativity. So Utzon, Arup, and Hornibrook did bring their expertise together to produce volumes, to define the anatomy, and to decide how to manufacture the various components. Now, what are the numbers? What are those numbers at the bottom of that image? And those are the numbers of the drawings produced by the various agents for the process. Okay? Now, the first one, the 100, is very optimistic. Okay? It's very optimistic. In the first yellow book, there are 4 drawings that have been used for the construction of the sails. Then we have models, we have sketches, we add other things that have been produced in response to the work of the others. With Arup, we have roughly between 700 and 800 drawings. With Hornibrook, we have over 5,000 drawings, of which I think 150, 200 were done essentially for the construction of the octopuses and the sails. So, that's an interesting issue. Where does it leave us in terms of authorship? Who is the author of this building? If we actually take drawings as a conventional way of exerting control over something and thereby stating one's authorship over the problem, over the building. Interestingly, this is a copy of the contract that was given to Hornibrook, contractor, where it says that we'll have to take instructions from the drawings, plans and specification prepared by Ove Arup and partners, not by Utzon. Okay? And so if we consider all of this, I think that that shows the importance of architecture, because there is no doubt that the Sydney Opera House is the product of one person's vision. And what's amazing about it is that it's a building that has changed its structure, it's changed its program, it's changed its configuration, but still remains the concept, the vision, the seed planted by someone, even though it wasn't even considered in the contract with the constructor. And I think that the sort of work that one can do through this type of analysis, so historiographic work, is actually very important. It's better than storytelling, because it is through the analysis of this documentation that one can understand the importance and the impact of people with great ideas over the unraveling of history. Now, historiography, I think, produces scholarship. And when I talk about scholarship, I mean our ability to transform raw data into critical information which is communicable to others. And here I'm also want to respond to Phil Bernstein that in a lecture in Australia, during a lecture in Australia a few months ago, not only called our writing a bit turgid, which is a criticism that I accept, but also said that he didn't understand my obsession with the columns of the Sydney Opera House. So, why are the columns of the Sydney Opera House important here? Why am I obsessed, but moderately interested in them? Because what we can see here is not only, in a sense, an alteration and modification to the initial idea that was made out of necessity, but something that defines a structural organization of the building. So if we don't consider those columns and we go by the conventional narrative, in architectural books, in Gideon, Rogers, Pierluigi Nervi, 1959, and so forth, we're going to put the building together in the same family as Saarinen's TWA terminal. What happens if we actually start considering that column? We actually realize that the solution adopted by Rice, Arup, and the team is very, very similar to the solution adopted by Pierluigi Nervi in the Palazzetto dello Sport, and the solution adopted by Sana at the Rolex Center where I work. That wall, there are 3 columns that are hidden away that do exactly the same thing that the column behind the Sydney Opera House does. And so by doing that, he actually gives us a chance to reformulate families, lineages, ways of work that are not just rhetorical, but also have to do with the way in which we respond to the challenges of our work. And almost last but not least, I think that doing this type of work really helps us illuminating the past. And by illuminating the past, I mean the ability to understand what is relevant in our history, in the things that would be worth preserving for the future. Now, that is an image of the Sydney Opera House with the very recent restoration, so in time for the 50th anniversary. And the one that you see on the left is a document that has been used for quite some time, Utzon Design Principles Adopted by the Sydney Opera House, which is a document of reference for the conservation of the building, or something that everyone should consider. The one on the right are, once again, the 4 hidden columns of the Sydney Opera House, and some of the little bits and pieces that were actually used for constructing the building. So if we are concerned with Utzon's legacy, by all means, let's look at the design principles of Utzon. If we are considered with the way in which the building evolved, developed, was constructed, then perhaps something to preserve and to put into the foreground are, for instance, those 4 columns that mark an incredible moment in the history of the building because allow the building to proceed, as well all the other bits and pieces that should be at the Smithsonian, at the Museum of Building in Washington, and the Victoria and Albert Museum. And so, in a sense, what I'm trying to say is that these are important elements because it defines our history. Buildings are us. And how we make buildings defines who we are as a society. And so one of the things that I want to put to you that, in fact, it's very important to know whether or to understand the relationship that might have existed at a particular point in time between Utzon and Saarinen, Utzon and Nervi, Utzon and Candela. But one also must consider that, in fact, the Sydney Opera House doesn't only come from that, but comes from the fact that a man called Manuel Hornibrook actually built this type of bridges in the 1930s in Australia. And it's by doing this type of work that for 30, 40 years, there was a culture of building, a building culture that was formed in Australia that not only, in a sense, responded to the challenges set up by Utzon, but nurtured that particular process. And so I guess this is my conclusion. And while I was coming here by car, I looked at some of the things that we published. There is one thing that came out 2 days ago for the anniversary of the building. And so I was trying to reflect on this, and I wrote just very few lines. I think it's important to understand that the Sydney Opera House, particularly today, is the result of the vision of one man. But it is also, and from our point of view above all, the product of a building culture developed over the years at a particular juncture in the history, and therefore the socio-technical history of a country. And then is actually proved by the incredible relationship that exists between architectural design and the worksite, the shop drawings documentation that was produced for the building. And I think this is the relationship that makes the building, the experience of the building, memorable. So while the visionary quality of the drawings of Utzon and their inevitable technical translation of Arup look towards a future has yet to be defined in detail, but very seductive, enthusing, intoxicating in its originality. The industrial practices that I showed you, that are contained in the shop drawings of Hornibrook, the builder of bridges, are the reflection of the society that built all of them. The reflection of society where all these bridges, all this work belongs. And of course, by that, also the constructive challenges that society had to meet until that moment to grant form to the infrastructure necessary for the country. And I think this is the tension, the autonomy, the complementarity of these different yet converging dimensions, the architectural, the constructive, the structural, that constitutes the kernel of what we are here to celebrate today. And that is, maybe involuntarily, I would say the ratification. Ratification is not the right word, but I have another one. Anyway, the importance at that particular point in time of the attainment of a physical and cultural identity for the country that's called Australia, as well its willingness to surpass it. And surpass it through the ideas of one visionary man, but also through the materialization, through the construction of the building, that for the ability to bring ambitions and reality together, deserves to become part of the heritage of all our professional worlds. Not only because of what it stands for, but because it gives us scope and hope for the future. Thank you very much.
Thank you, Paolo. I think you probably showed more working drawings in this room than have ever been shown in this room. And we have a few minutes for some questions if there are questions. Anybody? Questions for Professor Tombesi?
Hi, thanks so much for the talk. I'm curious, I don't know how much this is known, but I was curious about the attitude of the different contractors and Arab engineers in relation to such a challenging project. Like, do you know if I'm sure of course there's so many different people involved, you can't speak on how all of them felt, but whether or not they were sort of excited to sort of take the reins after Utzon was fired, or whether it was sort of placed on them without their sort of willingness.
Like I think this is a very interesting part of the story, because the Sydney Opera House is essentially three projects in one. So these are three phases, three buildings that were tendered by using completely different projects, completely different types of contracts, and each contract actually changed in relation to happened to the phase preceding it. The position of Arup is an interesting one in that respect, because he was actually acting as the project manager. So Arup was the project manager for the building, and it was Arup that actually decided that Hornibrook could actually be brought in as a nominated contractor. So in fact, if you look at the dynamics of that situation, you will see that the type of socio-technical relationships that were put in place changed from one stage to the other. One of the things we've done, but it's impossible to show on the screen because of the minutiae of those graphics, is to actually see how each party talked to the others by showing drawings, by showing quantities, by showing specifications, and you can see that at different times in the life of the project, this changes. Because essentially, as I said, buildings are us. So essentially define who we are and how we work with others. I mean, we could continue for long, but it's interesting. One last thing, I'm sorry, is that if you look at the difference between stage 2 of the Sydney Opera House and stage 3, stage 2 has conditions in the contract that allows you to take risks, essentially. Stage 3...
Will you translate stage 1, 2, 3 into US terms? Because I'm not sure these...
No, it's only the stage of construction. Stage 1 is podium. Stage 2 is the sales. Stage 3 is the theatres. So stage 2, the conditions of contract for stage 2, it's a cost plus and other things, is something that allows you to work on a problem. Stage 3, the conditions of stage 3 are conditions that allow you to work as efficiently as possible on something that is already defined for you by others.
In other words, the contractor on stage 2 didn't bid the project.
No.
He was simply paid whatever it costs to do that part of the work, which is very interesting, because you can imagine if that project had been tendered as a hard bid.
But it's interesting. It's interesting because if we look, I'm sorry, now we're moving the discussion in a different direction, but if we look at the escalation of cost through the life of the project, stage 1 and 2 take 50% of the cost, stage 3 take another 50. So if we look at the curve, the escalating curve, the difference in contrast didn't actually make that much difference.
Oh, wow. Sorry. That's interesting.
I found that interesting as well. I'm wondering.
I know, we all do.
I'm just curious whether you would attribute some of the national pride in the Sydney Opera House to the duration and the complexity of the construction, because surely people that were witnessing this, even if they might have wrongly attributed it solely to one person, their pride in it was more grounded in the fact that it took many, many hands over many years.
This is difficult to say, but there is no doubt that the building became part of Australian society, certainly in the state of New South Wales, and it became a very, very important building, even from a construction site perspective, because it was it employed thousands of people, and you can see that Australia is a multicultural society, and people from different construction trades would actually come from different ethnic groups as well. My colleague, I think, is Cardellicchio, once mentioned that 35% of concretiers, 35% were Italian migrants, of course, and where there is concrete, there is an Italian. But the thing is that this became part of the collective psyche of the country, and the construction trades have a major role to play in this. So, for instance, the trade unions, at the moment where the building became so overly exposed to public opinion, decided that was going to become the site for political struggle. And so they instituted something which was called the green bands, which meant that any time trees were uprooted on different sites around New South Wales, I think, or Sydney, then the Sydney Opera House would stop. And we're talking about the 1960s. Okay? And why would they do that? Because no other site would have actually held any importance in the public domain. But the Sydney Opera House was going to become the symbol not only of Australia, but of how Australian society would actually conduct itself.
Okay, last question.
Hi, I had a question regarding the materiality of the facade. Each of the components, I noticed, were also designed very similar to the drawing.
Sorry, I have difficulties in...
I had a question regarding the materiality of the facades. Did that also go through a lot of change? What's the history of how did it come to the facade material? Was it something that the architect had defined before, or did it evolve over time?
Well, look, one of my colleagues participate in this conversation. Do you want to answer this?
The facade.
Wait, let's get it.
Yeah, the facade is a very critical and controversial issue of the Sydney Opera House, because the very first option developed by actually Utzon wanted to explore the usage of plywood, structural plywood for the facade, but that was very innovative, and this also started creating a lot of controversial problems with Arup, and that's where the harmony between art and started to decay and where it actually stopped. And this was also the point where the government was a bit tired of Utzon as well, because Utzon was pushing the boundaries, of course, of architecture, but at the point of also pushing the boundary in
wanted to developing this plywood facade. And so what happened there is that the government said, we are not going to pay for your mock-ups for the plywood. We're going to use steel. And when and at the point, Woodson say, if you don't pay me for the mock-ups, I had to resign. And the government say, okay, yes, you can resign, you can go back to Denmark. And that's what actually happened. And so eventually, as we saw, Woodson was replaced by Peter Hall. And Peter Hall designed a facade. They did a little studies with concrete first, and then they went for steel. And the final facade is actually, that we have today, is actually steel and glass. Yeah, but that plywood experimentation that Woodson wanted to push is there where Woodson, I think, went a bit too beyond his beyond. This is it for the facade.
Thank you. All right, Paolo, last question. Why did Lutzen get fired?
Say it again?
Why did Lutzen get fired?
Oh, so, well, Lutzen resigned. He resigned.
Yes.
He resigned, I think, on the...
on resignation letter, right?
No, on the belief that, in fact, the government would bring him back. And this didn't happen, as we know. It was actually brought back in 1995, 2000, in order to finish the building, to finish parts of the building, or to make addition to the parts of the building. I guess what we've been trying to do here is to try and move away, sort of kidnap the author for a moment and put it somewhere else and look at the building. And when I'm asked why it resigned, what happened to it, to a certain extent today, I wonder whether that has any importance with regard to the building. I mean, I'm not particularly Ruskinian. I don't believe in the seven lamps of architecture, in the honesty, in the rigor, in the integrity of the project. And I look at this building, at the Sydney Opera House, that remains the Sydney Opera House, regardless. So in a sense, it is the idea, is that seed that was planted from an environmental perspective, from a sculptural perspective, from a spatial perspective, that stayed and is to the scrutiny of time. And so I'm not particularly.
You don't care?
I don't care. I don't care. Okay.
Thank you, Paul.
Thank you very much. Okay.